The Dauch Advanced Manufacturing Laboratory gives students access to technology that allows them to practice the skills needed for various real-world manufacturing roles. PTC's Digital Performance Management Software, or DPM, gives students a comprehensive and always current view of performance on the line, so they can learn how to continuously optimize and improve the production process, solving critical problems that save time, money, and energy. DPM analyzes real-time production data captured with Kepware, PTC's industrial connectivity platform, which fuels DPM's analysis by connecting millions of data points from PLCs and sensors on the line. This data includes the sequence of steps on each station, the health status of each robot, values from smart tools, and more. When automated data isn't available, DPM also takes data from manual input. To kick off an analysis of the line, DPM focuses students on bottleneck constraints, so they can quickly identify the biggest slowdowns and prioritize high-impact performance initiatives with up-to-date data. In our case, bottleneck analysis shows that the board assembly work center is the biggest bottleneck. Drilling down into this work center, we can see the effectiveness of the line during scheduled time. This is the performance while labor is present. Here, we can easily see the biggest categories of lost time, like changeovers, speed losses, and scrap, which are all standardized to time and presented as hours lost. In our case, we can see that the most production time is being lost to scrap. For even more detail, we can dive into the scrap loss category to see its specific loss reasons: rework, damaged parts, and missing parts. With this analysis, we now know the specific area on the line contributing the most to our time loss, the area with the highest impact when solved, so we can focus our improvement efforts on it. Students use DPM's Action Tracker, which manages their improvement efforts and tracks the value of their improvement initiatives. In this case, the first step is to analyze the root cause of the scrap. After investigating the line, the students discovered a design flaw. The fixture for the longboard truck was initially designed so that the truck could be inserted in any orientation. This led to parts being assembled at the wrong location on the board, resulting in scrap. To regain this lost production time, students decided to redesign the fixture so that it only allows operators to insert the truck in the correct orientation. To track and measure the impact of their improvement efforts, students return to Action Tracker, which lets them record the actions they took to solve the issue, then tie these actions to real production data to ensure the initiative reduced scrap. A month after the redesign, the students see that their actions significantly reduced the amount of time lost due to scrap. With digital performance management, students learn to proactively identify production issues causing bottlenecks, analyze root causes with comprehensive, up-to-date machine metrics, and make data-driven production decisions. This standardized, closed-loop approach to problem-solving helps students learn how technology can support manufacturing improvement and optimization, giving them a real-world learning experience.